theoretically live. Hey everyone, welcome to the virtual star party for, man, I don't even know. Sunday. It's always Sunday. May 31st, 2020. For some people, it's June 1st. Some of the people, actually not quite. Actually, one person is. So, this is the last time you're going to see me looking like this. Now I'm going to sort of hide like the rest of the, be one of the small boxes, like the rest of my participants. So, all right. So joining me tonight for the virtual star party, we've got on my screen right now, Dave Dickinson. Hey, Dave.
Hey there, in Norfolk.
Show the book.
Yes, I actually got this week in the mail. I'm like, what do we have in the mail coming? I don't think we have anything ordered. And this is the first time I've actually seen it. So it looks pretty good.
That's awesome.
Entire field guide to observing. We did best objects. We had our cutoff was about 10th magnitude for brightest objects, but we go the sky month by month, northern hemisphere, southern hemisphere, and we go through all the naked eye stuff. We got to do some mythology this time and just your direction and orientation in the sky, and then we go down through and break down all the telescopic objects per section. Again, best objects. We tried to just 200 pages. We really had to kind of slim it down to the best of the best double stars, best variable stars, best deep sky objects down to 10th magnitude. So,
and when is it coming out?
July 21st.
Awesome. Okay. All right. And we've got a bunch of different people tonight, which is great. Oh, what have I done? Okay. Sorry. Apologies. I got a lot of windows on my computer screen right now. All right. So we've got a new astronomer, Linda Thomas-Fowler. Linda.
Hi, thanks, Fraser. Thanks for inviting me on tonight. I'm in Northern Virginia, just outside of Washington, D.C. And despite the light pollution, we've got great clear skies tonight. So I hope to be able to bring you some fun stuff.
That's fantastic. For color commentary, we've got David Farina. David.
Hi, Fraser. How's everyone doing tonight? I'm really excited to be on here, and we'll be not showing my views through the telescope tonight, but within the next 2 weeks or so, I hope to be able to do that for you.
And so just to give people some context, who are you? What do you do?
So I am a high school astronomy and geology teacher, and I also run cosmossafari.com.
Awesome. And so you will help explain some of the things that we're looking at and talk about, because people are going to ask a bunch of questions about how to get into it, where to, recommendations on telescopes. So I hope you can jump in and pitch in with that.
Sure
awesome.
Thing.
All right. And a blast from the past. We've got Shah Ahmad, Shah from Malaysia in the daytime.
In the daytime. Hey, Fraser, guys. I'm Shahrin Ahmad, Shah from outside Kuala Lumpur. Not inside Kuala Lumpur, it's about 10 kilometers away. And at the moment it's 12 noon. And I'm on top of my roll-off observatory on top of my house, and it's really, really hot. Over here.
I love your observing tent that you're inside.
Yeah. And I got Venus now, so probably I can show you Venus at a really close.
Well, before you do, I just want to let people know a couple of things that we're going to try to do tonight. So for those of you who... So each week we're trying to just make a bunch of improvements to the star party. So we are having a daytime astronomy, which is great, from the other side of the world, from tomorrow in the future, which is wonderful. But we are going to be putting a whole bunch of pictures into a special Google Drive directory. So I think it's been posted in the chat. We'll put it into the show notes. Nightbot has listed it there. So we're going to, as we take pictures tonight, we're just going to drop various objects in there. Raw data, if you want to try and mess with the data, go ahead and fill your boots. And hopefully you'll get a chance you'll have some souvenirs by the time the party is over. But right now the directory is empty. But then stay tuned as we will be dropping a whole bunch of folders, a whole bunch of files into that directory. So. All right, let's get on with it. So Shah, yeah, by all means, please show us while we're still waiting. I'm still waiting for it to get a little dark for the observatory I'm running. Definitely, please let us see your view. That would be awesome.
Okay, I'm going to share the screen. Okay, before I share the screen on Venus, at the back over here, I think you can probably see it. That is the telescope that I'm using, a Skywatcher 120 ED with a focal length of 1800 mm with a Barlow 2 times. And that small red little thing at the bottom, that's the camera that I'm using. It's a ZWO ASI 120 MCS, if I got it correct. And you can see the long hood at the top. Probably if you see it up there. That's how I'm trying to avoid the sunlight coming in through the scope and burn my camera all the way to the ground.
Yeah.
It's really close. So, okay, I'm going to share the screen on Venus at the moment. Okay, here it is. Can you guys see it over here?
Yep.
Fraser? All right.
Just let people know that's an incredibly difficult observation to make when Venus is that close to the sun.
Yeah. So you can see the crescent is actually pointing upwards. You can see the mouse. Can you see the mouse moving? Yeah. All right. So that is the crescent of the Venus pointing upwards to the sun. So at the moment, I think Venus is shining about 0.3% illuminating, if I'm not mistaken. And it is really close. It's about 4 degrees, 17 minutes to the sun. So it's really, really close. And in fact, the observation that I'm doing now is I broke my own record back in 2014 when I was doing the same thing. That was in January, I think. So that
I remember
was about, yeah, that was it. I think it was about 5 degrees and 0.4%. So now I got less than 4 degrees and 0.3%. So it's a good catch. And
so just to give people some context, right? That is like you are 8 moon diameters away from the sun.
Mm-hmm. Yep.
That's so close. Like if you tried to look at Venus, you'd hurt your eyes.
Now, Shah, you said if you were to move it any more closer, you're concerned about light coming in from the sun then?
Yep. Yeah. So that's why I extended the hood of the telescope and put another long roll of black cardboard all the way to the other end. So just to make sure there's no sunlight dropping inside all the way to the camera. So it's pretty scary. I'm half expecting to smell something burning at the back over here.
On your camera.
Yeah, but yeah, I mean it looks okay. It's not too bright because the sun, even though it's close, I can still see some contrast between Venus and the sky behind. And the sky, my sky at the moment is a bit hazy, so it should be better than this. But yeah, I'm glad I'll be able to get it today.
So is Venus moving closer and closer to the sun, or has it come out the other side of the sun?
It's going to be the closest on the 4th,
Wednesday.
I think on Wednesday, Thursday, yeah.
Wednesday the 3rd, yeah.
The 3rd,
that would be, I think, less than a degree, I think. Less than 1 degree from the sun. I will not point my telescope to the sun at that time. It's going to be really, really close. Probably I will give it another try tomorrow if weather permits. But
break your record.
Closer than that, any closer than that, I'm not going to do it.
It's amazing how fast it moves when it's near inferior conjunction, because we just lost it in the evening sky. And probably by mid-June, we're going to see it in the morning sky. It will start popping up. So,
on the 3rd, it's 29 arc seconds away, so less than a half of a degree.
Oh wow! Okay.
No transit this time, so not like 2012 when we had the transit.
Oh yeah. No, we're going to be long dead when it transits again.
2117,
yeah, or onto our robot bodies. That's amazing, Shah. So you're going to try and get the sun now, right?
I have the hydrogen alpha telescope.
I was going to say I was looking with the PST earlier today, and there were a few prominences, so there may be some action. There's no sunspots right now, but
I'll give it a try.
All right,
just give me a few minutes.
That's awesome. Okay, yeah, you let us know when you think you've got it, and if we see like fire on the screen, we'll warn you.
Sure.
Awesome. All right.
All right.
So, Linda, you have been gathering data before we got started, and you've been gathering an image of M101. How long have you been been gathering this data for?
Well, I think about 110, 115 minutes. This is a single M101 sub. This is just 1 minute. So that's not very exciting. But this is 115 minutes of them stacked together.
Wow. That's beautiful.
And so pointing up there, I guess we're in Ursa Major or somewhere thereabouts. And I'm surprised that looks that good for that short amount of time. I've actually been working on this with my mono camera and was a little bit grumbling to myself tonight that I wasn't actually getting these subs for that image, but this is kind of cool to watch it come in live.
This is a piece of technology that I want to try and figure out, because I think it's great to see it just, your image just improves more and more each time, and like over, until you can sort of stop displaying it when you're sort of done with the image. I think that's great.
It does. I can actually stop this and the subs are all saved on the drive, and we can replay the stacking live if you'd like.
Oh yeah, that'd be amazing. I'd love to see that.
All right, let me stop that so no more come in. And then we will clear that.
And so I think this is great for people who want to understand a bit about how astrophotography works. You start with a, with short exposures, and then you stack up the exposures one at a time.
Stop that.
And each exposure adds a little more data and helps you remove a little more noise from the overall picture. And so in many cases, when you hear about an astronomer doing, say, 70 hours of observations, that's what you can see.
So you can see as it's stacking them here, the noise level is going down. Now it's not going down as much as it could because we're not doing other things like dithering.
Yeah.
But still, you can see the detail come out in the arms that you can't see in a single sub.
That's really cool.
So an astronomer friend of mine said that for every 7 images, you basically cut in half the amount of noise. So does that seem to be what you experience when you're doing the live stacking?
I might be accurate. I mean, we're going in here a minute at a time, so it's there's not a lot of time. So you can definitely see the noise improve. It's not that the detail improves so much, but the noise goes down and allows the details to be seen.
Right.
Yeah, that's really cool.
So this is probably the best I can give you tonight because I've been working on it for an hour before we started.
Yeah, I'm gonna try to take I'm taking a picture of it as well, but I don't have sort of good hopes for it because the moon is up in the sky, and I'll try to take a picture of the moon tonight. But it's, again, not the right machine for being able to do that. I don't know, Linda, are you able to take a picture of the moon?
I can give it a try.
Yeah, give it a shot. I don't know what the exposure is, like a 1/100th of a second or something.
Yeah, you're down to,
Linda, what kind of telescope are we using with your setup?
It's a Stellar View SV80 and 80 millimeter apochromat.
So it's actually very similar to the telescope that I've got collecting dust behind me here. That's a 70 millimeter. So you've got the 80 millimeter.
So that's a focal length of 480 millimeters. Is that accurate?
Yes, it is. Oh, the moon's pretty low for me. It might be behind a tree. Let me give it a try.
I can try as well.
I've got the world's worst horizons.
So you're pretty cropped in your image then, Linda, when you're going to that, or that's actually about half a degree in diameter. So that's actually a pretty big object. It's like the size of the moon, right?
Yeah, I mean, the moon will fit in my field of view.
But I'm saying the M101 that we were just looking at is also fairly big, but just very dim.
Yeah, it's, let me jump back here. And in my field of view, M101 is fairly small.
Okay.
Yeah, so you got a nice wide field of view.
All right.
And a lot of dust spots on that filter.
Brian Cox is asking, what camera are you using?
This is a ZWO ASI 294.
Okay.
It's So this is a color camera. This actually isn't the camera that I normally use for astrophotography. That's an ASI 1600, but I put this on for tonight so that we could see some color.
Oh, thank you so much. Yeah, everybody knows I like the color cameras.
I always thought M101 looks kind of like what our galaxy might look like from the outside. I mean, it's a wide spiral with kind of a tight bar in the center.
Yeah, astronomers, I mean, are still trying to figure out whether or not it's...
Too much.
Oh, there you go.
It's gibbous, you can see that.
Yeah.
Let's try...
So what was the exposure on... What was your exposure on that?
That's 100th of a second.
Yeah.
That's still too much.
Too much, yeah.
Wow.
I can crank the gain down too.
So I'm reading here, M101 is 170,000 light years across. So it is a lot larger, though, than our
than our galaxy. Yeah.
Because we're 120.
I just can't get this.
That's what, 1/500th?
That's 100th of a second there. It's just too bright for this combination. Let me try.
I'll try as well.
Oh no, if I do, I can't switch that. I'll mess up my cooling.
I've walked away from my telescope many times seeing the moon, even though I'm not looking through the eyepiece anymore.
Yeah.
On the Dob, I'll have like a 12-inch Dob, and I'll look in the eyepiece and be like, "Whoa, that was a little much."
So I've tried a 1,000th of a second, and that was okay. On the with the
it's
Rasa.
like shooting with the DSLR. Yeah, so it's about 1,000.
Yeah, I'll try like a 5,000th. Oh, won't even. I can't even do it. That's the shortest I can do in exposure. So. Can I do anything else?
Yeah, this software is let me turn off that auto stretch. That's a little bit better.
The moon is full. Oh yeah, Friday there's a penumbral eclipse. I just remembered. Yeah, we're going toward full.
There we go.
Oh, good.
Nice.
We don't see that eclipse, but I think it's Europe. I think those longitudes get it.
On Halloween a couple years ago, we had a full moon, and I set up a C8 in the front yard. And for the record, kids will still not give you candy to look through a telescope. But you can blind them with a full moon pretty effectively.
There you go.
Yeah, so here's my moon. It's a little overexposed. And I can't take a shorter exposure. Can anyone think of a way that I can go I'm not even allowed to go shorter in the sky.
Can you turn the
doing an
camera
auto
on your
stretch?
camera?
I'm not stretching it at all, so no, I can't.
Well, it might be by default. If you right click and select none on the auto stretch, it might help.
Yeah.
We're still seeing Linda's screen as well, so it's hard for the audience to.
Are you not able? Were you not able to see mine?
On Zoom, they were seeing mine, but I stopped sharing.
Okay.
Yeah, no, yours. You can leave yours up, and then I can put stuff in front of it.
Okay.
So yeah, definitely leave yours up.
Fraser's, yours looks like the Russians' first picture of the far side of the moon.
Yeah. At some point, we will get. Well, I mean, when Corey's here, we've got a nice proper planetary system. Although he's generally trying to take data to grab his pictures, we need a nice color planetary setup. So that'll come. But there's yours. Oh, it looks great. Yeah, wonderful. There you go.
I don't have a way to color balance in this software.
It looks a little greenish.
Yeah.
Oh yeah.
So the brightest, or the biggest, I should say, crater there is the Copernicus crater, that prominent one that's about almost to the center, right next to the Terminator. There you go.
Yeah, my gain. So people are asking, I can drop my gain. My gain is already all the way dropped. unfortunately. Yeah. No.
Oh,
So I
didn't
need to
get
I need to
that.
wait for less moon. Awesome. Well, I've got so I took an M13 and I actually put it into that folder. So hopefully people let me know if you can actually see it. I put it into that folder that I put in the chat. But I will show you on the screen what it looks like. Let's see. There. Okay. So this is the M13, the globular cluster in Hercules. And this is a nice bright object. So I like to take this.
Yeah, this is a Star Party favorite. It's an easy one to find.
Yeah, absolutely. It's sort of like, as soon as the skies get dark enough to take a picture, this is the first thing you take a picture of.
22,000 light years distant.
So last week, I don't know if you missed it, David. We went after some pretty interesting targets. Chris had
I
us
heard you
chasing...
on Astronomy Cast. I heard you talking about it.
Yeah, we went after the whale, which I'd never done. So yeah, we went after the sombrero, and then a bunch of like really interesting targets that I'd never seen before. So I'm gonna need you to dig a little deeper tonight. Is what I'm saying.
There's another globular if you're up toward Hercules, M92.
Sure. Yeah.
That's pretty bright.
Okay.
And you probably could get some stuff. I think all the stuff toward Lyra and Cygnus is still too low for you right now.
Yeah, well, that's the hope with Linda, is that we'll be able to get some of the stuff in Lyra tonight.
Yeah, that stuff is up higher for us on the East Coast here.
So just to show people here, I'll bring up the sky. So here's the sky right now, and so for example, the moon. You can see where the moon is now. Last week we were in Virgo looking at all those amazing galaxies in Virgo. Well, the moon is in Virgo now. So a lot of the objects that we're going to try to see are all collected in this exact same area, unfortunately.
Fraser, there's also the Cat's Eye Nebula near Hercules up in Draco. I don't know how that rig of yours does planetaries, because that's a little smaller. But
which one?
The Cat's Eye Nebula.
I think I've taken a picture of that before. I think it should work. Yeah.
Okay.
So you grabbed an M101. I just grabbed an M101 as well. Let me see. But it's going to probably be... I haven't even taken a look at it. I think it's going to be a little blown out from the light pollution from the moon. Oh, and it's blurry. So mine's going to... Or it's a little jiggly, I believe is the technical term.
It's getting occulted by the moon. No.
Yeah. Whoops.
Fraser, I shared my view on the moon last night. I was doing a live as well. So here's a recording of the moon last night. It's just a short video of it.
Oh, great. Okay.
Yeah.
Oh, wow.
So it's focusing on what's the name of the crater? Like Plato, I think.
I think so.
That's Plato, yeah.
Yeah. Let me adjust the brightness a bit.
So the planetary is interesting. Do you do any stacking from the videos that you make?
Yeah, I did. For this photo, okay, let me share. If I got a picture somewhere on here. From the same video that I took on Plato over here. Let's see now. Share.
So you do like the lucky imaging, where you're looking for the best atmospheric conditions rather than simply the best or longest exposure, right?
Yeah. Usually I just pick about the best 10%, 20% of the whole total image or the video, because the rest would be just really blur. Okay, here's the one that I've stacked.
Wow.
Oh, that's great.
Yeah, from the same video just now. So I think I stack about 10%, I think 20%. I can't remember.
What would you say is the most important factor when trying to take a good picture of the moon like this one? with the detail.
The seeing is important, but for me, because my observatory is on the house, so I got a lot of heat coming up from the roof, so I will not get a really perfect seeing anyway. Saying that, I love imaging the moon during its half phase, during the crescent phase, where you can see the shadows, the night and the day part. Yeah, because during
coming in from an angle.
Yeah, the full moon is too bright and too boring. I don't like the full moon.
You're looking at, there's no shadow. The shadow contrast, definitely.
Yeah. And I did once, I imaged the moon about 3 hours apart on the same place. So you can actually see the shadow shortening a bit because the sun goes up a bit between that 3 hours. So it's really interesting. Probably I'll give it another try in a couple of days, probably.
My wife and I were out. Go ahead.
Oh, I was going to say the illumination angle is not always the same each lunation either, so it's kind of it's always worth looking because some features can kind of pop on one lunation and not another.
Yeah, sure.
My wife and I were out on a walk today, and my son, for the first time ever, pointed at the moon and said "moon," and I said to my wife, I said that it's amazing now that we're watching the launches from SpaceX and NASA that I never really thought about it before, that people are still alive that have watched people go to the moon. I haven't. I'm not old enough to have seen that. And it's exciting to me to know that maybe within the next few years, I'll be able to look at the moon and not only see the moon, but know that somebody's up there.
Yeah. Well, I mean, when you think about how there are permanent people on board the International Space Station and have been that way, for 20 years, right? So we'll have that.
Since 2000,
Yeah.
I caught the very last Apollo launch, I think, was 17 when I was like 4.
I guess I was like 2. So FPV Reviews asks, what optics or resolution would we require to take a picture of the Apollo missions, I guess, from Earth? Even the Hubble Space Telescope can't do it.
No.
It's too small.
Oh, you always get that at star parties. Everybody always asks, "Can you see the flag with that thing?"
Yeah,
it's like one of the number one questions you get when you're observing the moon.
Oh, yeah. Fraser, don't have permission to upload into that folder.
Okay.
I was gonna say that.
All right, let me change the sharing on this.
Yeah, I was hoping to get some shot on some meteorites falling on the moon while recording. That would be a very lucky shot.
Well, during the eclipse, there were the people that caught that meteor impact.
Yeah.
Yep.
Yeah, that was cool. That sent us all scrambling, looking back through because we were all imaging at the same time.
Yeah, I wasn't shooting video. I was taking like a frame every few seconds at that point, and I missed it.
I was in Tarifa, Spain. I went out early that morning and watched just with my camera and was up shooting. It was very cool.
It was very cold here too, and very windy.
All right, so I'm going to I'll see about getting you access to that folder. I dropped another file. I've dropped my M13 in there. I'll drop my M101 in there. Sort of got a million. I sure do appreciate having other people here. So I'm like wrestling with technology. It's great.
Yeah, and I will be placing an image in there at some point of my M13, but I'll also put an unedited file in there if anybody wants to use that, take it, edit it.
So Nancy, if you're watching, I gave you editor permission on that directory. So if you can send invitations to David and Linda and Shah, that would be wonderful. If you're watching. I took Magid77 is asking, in planetary stacking, do you use raw or JPEG images to do the stack? Shah, are you using raw or JPEG to do your stack?
For the planetary images?
Yeah.
I recorded it in the video format, the SER format, SER format. That is a raw video file. So when I stack it, the final image will be in TIFF format. So I will not save it in JPEG unless I upload on the internet or on Twitter. But the final stack image will be in TIFF. At least it will store as much data as possible.
Right.
Yeah.
All right,
Shah,
Dave, I got your picture.
Oh,
I got your picture.
cool.
So here's your Cat's Eye Nebula.
I was gonna say it's teeny though, yeah.
Yeah.
So that kind of wider image isn't that great for it.
Yeah, you need like a
only an
planetary
arc minute
camera
or two.
to get it. You can see the little blue blob there.
Yeah, it's actually it's kind of cool to see when you have it's only like 20 arc seconds across. So that's why it's a planetary nebula, because it has a disk about the size of a planet.
The one thing that is kind of cool when I took this picture though is we got a little bit of a star trail passing through it. I don't know if you can.
Probably Starlink. We'll just call it Starlink. So.
Poor Starlink. Oh.
Something I learned in research about the Cat's Eye Nebula I didn't know is this one is very close to the northern ecliptic pole. When I was looking for just like some of the landmarks in the sky to put on the maps, so perpendicular to the plane of the ecliptic, the northern pole points almost exactly to the Cat's Eye Nebula.
So so you can see my my satellite trail here running through.
It kind of flared a little bit when it went through.
Yeah, it's interesting. It did. It flared up a little bit as it went through the screen.
Either a tumbler, like a booster tumbling, or maybe a solar panel caught the sun just right for a second.
Yeah. All right. So Leonard Lindstrom is asking for M91. You got it. I will. I'll go after M91. Barred spiral. Yeah, but I can't guarantee it's going to look good because of course, the stupid moon. Oh, it's right beside the moon. All right.
Yeah, all those galaxies in the bowl of Virgo are kind of off limits tonight.
Yeah, so we won't be. So I'm just going to get like a completely washed out nightmare. All right, and then I will show you the M101 picture that I took. It's not.
Is the supernova still bright? The one in M61, is it still bright? Or?
I don't know. It was a few weeks ago. I haven't looked at it lately.
Yeah. All right.
Shah, I was just thinking, are you going to the annular eclipse in a couple of weeks?
That was the original plan before.
Oh, that's true. You can't travel.
All hell.
Well,
yeah.
Well, I think you still get a partial. There.
Yeah. From Kuala Lumpur, I think about 10%. I think. Yeah.
Yeah. So
I'll probably be doing some live streaming as well during that day. So hopefully the weather holds.
All right. So I will. I'll take a shot. I'm gonna take like a short picture of M90. Was it of M91? So I don't like our chances on this one. Like I said, it's so close to. I'll show you just some context here. So there's the moon, and we want M91.
So there is an M13 TIFF file in the Google Drive in a moment for everyone if you're interested in trying your hand at doing an edit of your own. I also put my my edit in there as well.
Oh, great! Yeah, so we'll put the FITS file in there, and then people can.
It's going to be in TIFF, so you can do it in Photoshop or another software as well. So I'll put a handful more in there as well, folks, if you're interested.
So there's the moon. And so there's M91. And so you can see how close. Look at all the galaxies in Virgo.
Yeah, I see a bunch.
It's just so many. It's crazy. And so there's M91. And that's what it would look like. It's beautiful. But
I think about a third of the Messier objects are just Coma Berenices in Virgo in that area.
Yeah,
I believe I remember counting up when I was going through and tallying for the book is like about a third of the objects are just in that area.
And so the thing is that this is the Virgo supercluster. And we always talk about this idea that we're in the Virgo supercluster. Can you resolve Capella as multiple stars?
Not with that wide a field of view.
I don't know what you need to be able to do that. I'll take a picture of Capella if it's up. Is it up? I got
in Riga. No, I don't think so.
No, there it is, right underneath the horizon for me. So.
I think it's not. I think it's a really close double too. I don't think it's a great telescopic double.
Yeah.
Capella.
Tony Semenek is asking, are the Trifid and the Lagoon Nebulas up for me yet? No, they're not.
Give it another month.
Yeah, probably another 2 months. Yeah.
July or so we might start getting
into July, into August probably.
Yeah.
I think
threw Trifid and Lagoon in the Google Drive actually as he said that.
Oh,
so
great.
There's a RGB. So the first one was just one shot, and the other one is an RGB image. So you're gonna have to combine them. So if you want a little more complexity, you can try your hand at editing an RGB image.
Oh, awesome. Yeah, so there's the Trifid Nebula there, just above the horizon. So it'll be moving up higher and higher each week. So right now we're in galaxy season. Don't savor the moment. Ooh.
You might be able to start going after some of the globulars in Ophiuchus or Serpens, like Serpens kaput. That's probably doable.
Yeah. Any luck with the sun, Shah?
No, because I tried as much as I can. I can't get any prominence showing up.
But
on the
can you even
camera,
get the sun?
So I got it, but I didn't get the prominence.
I didn't see any fires comting out of the back of the telescope quite yet.
I'm bad at solar imaging on H alpha, so probably I messed up with the settings, but I couldn't get anything much.
So you can't even tell that there's like a giant thermonuclear explosion there?
There were some about 12 hours ago when I looked, but the sun changes too. It might be the case there's no activity now, but there had been yesterday and today.
So just to show you here, I took the picture of M91 for you, Leonard, and it's not good.
Yeah.
So I need to get away from the moon.
I've got 2 minutes on M106 if you want, Fraser.
Oh, great. Yeah. Share it.
That's right. I'm not sharing.
David, give me a target. I'll go after the owl.
Try M5 down in Serpens.
Okay.
That's a good globular.
All right.
I'm glad that you're pronouncing it two different ways, because I always find myself, do I say globular? Do I say globular?
This is a long discussion from way back in the old virtual star party, believe me.
Yeah.
My third book is just going to be on pronunciation.
All right. Let's move over to... and we'll try Pan-STARRS again tonight, I think.
Yeah, it should be still pretty bright in Ursa Major, I believe, still.
So that's the comet that broke up? Is that accurate?
No, this T2 is, they found it in 2017, and we knew it was going to be a good, but the one you're thinking of is Y4 Atlas. That was touted as going to be a fairly bright comet, and then it kind of broke apart.
What's the one that's up in the morning then, right now?
F8 Swan.
Oh, that's Swan. That's right.
Yeah.
Okay.
Yeah.
Futura.com is asking, have anybody ever observed a supernova?
Oh, we did a few weeks ago.
Yeah, we looked at the supernova a couple of weeks ago. And
we
of course, we also discovered one a couple of years ago. We just didn't realize.
We had a pre-discovery image.
Yeah.
M82, wasn't it? Yeah.
Yeah.
Yeah. And who was it that was doing the narration that he actually said, this galaxy isn't a big producer?
Was it David Dunn? Yeah, I forget who it was who actually said that. It was so funny.
Like, this galaxy generally doesn't produce a lot of supernovae while we were looking at the supernova.
I used that recording for my talks in schools, so they were laughing out loud.
It's archived up there on YouTube forever.
Yeah, it's just a reminder to just double check. And now, of course, every time, Dave is always taking a good look. Yeah.
I pull up the Wikipedia image and kind of look at it and see if any stars are out of place.
Now,
That's
most
great.
of that is done by software in the professional observatories, I would imagine, that they're doing kind of like a comparison digitally.
I think so. Yeah, I think so.
Yeah.
But there are, and I heard you and Pamela talk about it, Fraser, a few weeks ago. There are amateur supernova hunters that really have the star patterns kind of memorized.
Yeah, yeah.
That's
so
incredible.
that they can look at different galaxies and that's and spot something out of place.
And so
I want to go ahead, Fraser. Sorry.
Oh, I was gonna say. So which is this one, Linda?
This is M106.
Okay, and so just to show people again, we are battling the moon tonight. So this is.
My personal goal is I want to be able to see the sky in like more three-dimensional. The first step towards learning the sky is, of course, finding the patterns. And I'm at this point, I've done teaching astronomy and running a planetarium for 10 years. And I kind of have eliminated the vast majority of my two-dimensional understanding. So if I can start to memorize distances and kind of see that depth as I look out at things, and it's got to be here. It can't just... I can look things up, but I feel like if I can get it to stick in my brain, it'll just kind of change my perspective a little bit.
Yeah.
That's something I tried hard to get the distances in the tables for the objects in the new book, because I always get that question at star parties, like, well, how far away is that galaxy? Or I wanted just a quick reference to like get an idea.
All right. So I got your, let's see how your picture came up, Dave. M5. So you can see M106 is below Ursa Major. So if you know where Ursa Major is, there's a lot of galaxies around there as well. You can see sort of like just under the handle of Ursa Major. Oh, I need to focus. Okay. Clearly.
And I learned researching all these distances, I realized that open clusters, there's a lot of ambiguity in the distances in a lot of open clusters out there still, because you can go across multiple sources and get multiple different answers. Things like galaxies and stars, especially with Gaia out there, stars, we have a pretty good grasp on how far away they are.
So there's your globular, M5. It's got a bright star right beside it.
I believe it does, yeah. This one is 23 arc minutes across.
The object.
Yes.
What's my zip code? I'm using San Bernardino, Tony. So it's like it's in Landers, California. Sort of kind of close to Palm Springs as well. But San Bernardino's pretty close.
The star you're probably getting right next to it, there's a 5th magnitude star that's 5 Serpentis.
Oh, okay. All right.
That's probably what you're seeing.
Yeah, and I've definitely got to refocus the camera. You can see my stars are little blobs. So I'm going to refocus. Which you kind of have to do as the night gets a little cooler and the telescope optics change a little bit. You want to refocus.
Especially with that fast a telescope.
Well, I mean, you always want focus, right? It's like, I feel like it's one of the hardest things for me to get, especially when I'm doing when I'm just like trying to take pictures through the telescope, or like trying to take pictures with my DSLR. Focus is just what I spend half of the night battling with.
You use a Batinoff mask, Fraser?
No. I just when I just take my DSLR camera out and just take pictures with it.
Oh, okay. I see what you see.
Yeah.
I remember I wasted about an hour of imaging. When I look back, the stars are all nice, big, and round.
Yeah.
only to realize that the camera was sliding down a bit. It's not properly locked.
Oh, so each time you take a picture, it's like slowly sliding down. Oh no!
You could make a nice animation of the stars going into focus if you play it in reverse.
Painter's tape. That's what I do.
Tony is saying Brian, yeah, the scope is at GMARS in Landers, yeah. And Tony's saying the elephant's trunk is up. Yeah, we can take a crack at the elephant's trunk, I think. Let's see.
Is that an emission nebula? I'm trying to think of which.
It's a dark
Yeah.
nebula.
Okay.
Too low. So
Yeah,
I need
and probably a
things
challenge with the moon.
Yeah,
I think
and I
that's
need
along
things
the
that are
galactic
about
plane as well.
30 degrees above the horizon, really, to go after. So
Yeah, it's behind a tree for me.
the Ring Nebula, I wonder then. I'm going to try. I'll try the
Lyra,
Ring Nebula
Yeah, that
Once
might
I'm-
look like something.
once I'm done focusing.
It's gonna be a little tiny.
The proliferation of informal names now, like the elephant's trunk or the shoe buckle cluster, or it's interesting that I mean, there's things that like the Beehive or the Ring Nebula; those have always been used, but it seems like lately there's a lot more informal names being thrown around for things.
Yeah.
I think there's a lot of amateur astronomers throwing names out there hoping they'll stick.
Yeah,
Well,
there you
I
go.
mean, the joke that I always like to make is the Pac-Man Nebula. How you
Yeah,
know,
or the Homer Nebula.
what did they
there.
call it? What did they call it before Pac-Man Nebula?
Oh, that's true. Before
Right.
Pac-Man was.
Yeah, if
I
they'd
don't know, but
known
it
about
is aptly
Nebula
named.
for a long time, what
Yeah.
did they call it? So
I don't know. Yeah.
I think if it makes people excited and interested
Yeah.
with the content, that's a good thing.
yeah.
Hopefully they
yeah.
dig deeper and they learn more.
So we should just go back and rename everything into, rename all of the objects in the night sky to something that's
Well, it's like the
more pop
NGC
culture.
catalog. It's I don't have I have most of the Messiers kind of memorized, but the NGC catalog, is kind of much larger. So
Yeah.
it's
Yeah, the pop culture names for all the objects, that would be an annual change in their names.
Oh, and then stars, you get into like most stars, depending on what catalog you're in, there's dozens of names for the same stars.
Yeah.
So,
So I'll take a crack at the elephant's trunk, or it maybe. No, I'm not going to be able to get it this week. I think
there
it's
you
just
go.
going to be too low. Oh, Linda, you got something? Oh, hey, there it
Yeah.
is. Oh, wonderful.
That's
yeah,
just
got a little color to it.
that's just the plate solve image. Let me get a longer exposure here.
Oh, that's great though. So fast.
Good.
I love the Ring Nebula.
It's much too small for my telescope, but this is 100% view, so you can actually get a hint of the central star there.
Oh yeah, you can. I heard a kid at a star party describe it as the ghost of a donut. That's what he said.
Yeah. It's a
It must
great
be hungry.
Yeah.
It's always interesting, that in about 5 billion years, our sun's going to do the same thing. It's
for
It's
the
kind of-
pleasure of some other alien star party. Where they
right.
just look-
Yeah, we're like, yeah. They're like, oh my gosh.
Argus RD saying, what's interesting to see right now with my binoculars in the sky from Patagonia, Argentina?
Oh, they got the large and small Magellanic clouds down there. Of course, the
Yeah.
moon is out right now, but those are always cool.
Yeah, I'm trying to think when they can see Omega Centauri. That looks beautiful
About
with their
now.
binoculars.
It's
I
up
think-
now.
Yeah,
I think
okay.
that's usually toward May and June, because you can see it from like when I lived in Florida, you could see Omega Centauri around late April, like April 30th or so. You could see it low to the south, but you could pick it out. We picked it out at star parties in Florida before.
All right, I'll try a Ring Nebula too. It looks like I can get it, so that's good. Ring Nebula's on the menu now.
Yeah, it's one of the better planetaries.
Oh yeah. And then I wonder where the Helix is at right now, because
The Helix is good because it's pretty large.
Yeah.
I think the Helix is the closest planetary, I'm pretty sure, to the Earth.
Oh, is it?
I think so. Without looking it
It's
up,
huge.
I'm pretty sure. Yeah,
Yes.
that's why visually it's pretty good size.
Oh,
No, that's not a good place for the Helix Nebula right now. So
I
we're gonna have
forgot
to
to
wait
turn
on that.
guiding back
It's in
on.
Aquarius, so yeah, it's not going to be a good target for
Yeah,
tonight.
yeah.
Let me retake that with
Yeah.
guiding turned on so we get round stars.
The Helix is one of those ones that just missed Charles Messier's catalog because it was probably a little too far south for him to pick out. it didn't get a Messier designation. It should have. It was bright enough, but
Yeah, it's funny some of the stuff that he took, and then some of the stuff that he
yeah, like M45. But
Yeah.
and yet he didn't put in the double cluster in Perseus.
yeah.
You know, it is odd how it went through many revisions. If you read how he originally, and you realize how horrible the optics were that in like the 18th century that he was using. I think it was a 3-inch refractor, but they were the best optics that were available of the day. But by modern standards, they were actually pretty terrible.
I'm always amazed at how good the observations that the scientists were making with those bad optics, though.
Yeah.
Because I have good optics and I can't see what they're seeing.
Maybe that's why you can't.
Yeah.
Yeah.
They were imagining things.
There's a few errors in his catalog. I think M40, I believe, was one that it's just like a small group of double stars or something in that region of the sky. So there's a few errors in his catalog too.
So I just took a picture of M51, which is all right, actually. And that's a 60-second exposure.
Nice.
Yeah, I mean, with the light pollution, it's actually with the moon, with the stupid moon.
Still with my f6 telescope, that's, I would need 5 minutes to do that.
And then I'll try the Ring Nebula.
Have you guys heard about this group in Australia and New Zealand? I think about 5 people. They call themselves Boss Backyard Observer Supernova something, I can't remember. So they were taking every night all the galaxies, 10-second images, 10 second, just to get some images of supernova on the galaxies.
Oh,
it's
wow.
a group work. I think about 5 people, Yeah.
Interesting.
Yeah. BOSS. Boss.
I've got a cleaner image of the ring now.
Oh, excellent. Okay, here, go back to your shot. That's fantastic. And
you can see the central star, yeah, even on my phone.
Oh, that's great.
Yeah.
What are the colors there, Fraser?
On the Ring Nebula?
Yeah. Do you know why they're different colors?
Well, so I mean, you're using a color camera, right, Linda?
Yeah. So
Yeah.
It's hydrogen and oxygen.
Yeah. So the central part is more in oxygen, and then the outer part I think is more hydrogen.
Yeah. The reddish part's the hydrogen alpha emission, and the oxygen is the blue-green teal color.
So we're seeing the outer layers of the star basically being shed, right?
Yeah.
And so so the when this star died, it just pulsed up as a red giant star, and then did a bunch of these pulsations in and out until it finally ran out of fuel in its core, and then compacted back down into a white dwarf. And so it let out these outer layers that expanded in space, and from our perspective, it just looks like a ring, but actually it's more like a sphere that is blasting out these layers. And each planetary nebula has a different shape. It just depends on like the magnetic, they think it depends on like the magnetic field that the star has around it helps to define the way those layers are sloughed out into space as they die. And so each one of these planetary nebula is a completely different creature. It's kind of amazing.
The dumbbell in Vulpecula is another good contrasting one that kind of has an apple core.
Yeah, let's see where the dumbbell is. So here, also,
I think it's too low.
Is it? Okay, yeah. So
I might be able to get it.
The beehive should be up.
So there's
you
my
were talking
Ring
about
Nebula.
doing some globs earlier.
And I'll drop a copy of this into the folder.
Wasn't there a study a few years ago, Fraser, that there was some controversy whether our sun would become a planetary nebula?
Yeah. There was a study about 3 years ago or so. Let me see. So yeah, there's a study about 3 years ago or so, and astronomers are recalculating whether or not it will definitely be turned into a planetary nebula, and they said that they weren't entirely sure, that it didn't have the right underlying qualifications to actually do that. I see some branches in your view.
Oh, cool.
It's
Yeah,
pretty
it's
close, but I think we'll be able to get the dumbbell.
Oh, cool.
Oh, great. Okay. Yeah. Yeah, and so we always say, I mean,
It's one of those star party things one of the lines we always give people that.
Yeah, we always say that, oh yeah, the Ring Nebula, this is what our sun is going to look like in 5 billion years, but the reality is actually maybe not, according to the most modern research. The other one that I like to debunk from people is people always say, most stars are in multiple star groupings.
Yeah, I remember that came around in the first book we did.
Yeah, and that's not true.
You could say most naked eye stars.
Yes, the bright stars that you can see are in multiple star systems, but actually the vast majority of stars.
I think that's how we re-edited it to say it's like, and I have to change my spiel at star parties now to say the naked eye stars you see, are mostly multiples.
Yeah,
because
exactly.
Ironically, the most common type of star in the universe, red dwarfs. There's not a single naked eye red dwarf in the sky. There's not one close enough right now to see.
So is anybody having any problems accessing these pictures that we're uploading into the directory? So let me know if that's not working for you. Well, this is the first night that we've actually tried to do this, so we clearly had a couple of hiccups in actually getting the other participants access to this directory. But so Shah, are you not going to be able to even show us a picture of the sun, even like a boring picture of the sun?
No pressure.
No pressure. Wait. Let me show you the current video of Venus. The sky is clearing up at the moment.
Okay, all right.
So I'll probably show it first.
We're in a profound solar minimum right now too. Like you're talking.
Yeah. I mean, so if you don't see any prominences or sunspots, that's fine. This is not on you. This is this is the sun.
All right. Here's Venus now. It's almost near the meridian. So after this, the whole scope will do the meridian flip all over the place, and I have to do all the alignment back all over again.
That's so cool, and so it's still even closer. Like Venus is even closer now. It's like an hour closer.
Yeah. It was closer than an hour ago, I think. So I'm breaking my own record.
Yeah, each.
As it gets closer towards Wednesday.
Yeah.
And of course, you are recording video of this, right? So you'll be able to stack up an image of it when you're done.
I recorded about 60,000 frames per video, and I've recorded about 5 videos. And currently, I'm running out of space, hard disk space.
Yeah.
So planetary imaging is bad for your hard disk.
So
it's just not enough space.
So you're asking, Ken was asking, what scope am I using? I'm using the one that's sort of down at the bottom there. That is the RASA. It's an 11-inch RASA, Celestron RASA telescope, and it is generously provided by Oceanside Photo and Telescope. And they let us use this amazing telescope. I mean, they use it for a whole bunch of other things, but during the star parties, they let us use it. Oh, that's amazing. That's wonderful.
Oh, cool.
There's 2 minutes on the dumbbell.
Nice.
That's great.
It just managed to sneak out from behind the tree.
Oh, and you got a Starlink. I mean, satellite trail. That's great. So, you actually got the tree branch in your picture.
Yeah.
I love that.
I can't, given the super high horizons in my backyard, I can't tell you the number of nights where I was imaging something, didn't realize how quickly it was going to go behind the neighbor's tree. And then the next morning, I look at these trees rising up through the frame.
So I've put a Helix Nebula in the Google Drive folder, both an LRGB version and a one-shot color version if you guys are interested to edit.
That's great.
And one of the ways I found when talking about planetary nebula with kids, elementary school kids, to get them interested is in talking about the stars, pulsing and pushing out these gas envelopes, is to just call them star farts. And they all go, ooh.
That's irresistible, yeah.
I do remember, coming up in research here that Helix Nebula is the closest planetary nebula to. It's about 500 light years.
Oh, great. Okay. and when you think about it, a lot of these nebulae are actually fairly like short-lived. Like some of the, like when you think about, say, the Veil Nebula, it's a supernova remnant, and we're seeing it only a couple of thousand, like maybe 5,000 years old, and it's just getting bigger and fainter, and eventually it'll fade away. Same with all these planetary nebula. So all of the planetary nebula that we can see are stars that did its dying in fairly recent history, in the last few tens of thousands of years.
Ooh, the coat hanger.
Oh, is that the coat hanger?
Yeah.
Oh, that's awesome. Oh man, Dave, I need some targets. I'm falling behind here. Linda's just charging forward.
There is. So give me a second here.
Talking about doing beehive cluster earlier, that should be up, and I think is wide enough.
Yeah, I'll do the beehive.
Maybe.
Okay, sure.
There you go. The
Difference
the coat
of
hanger.
topic.
Yeah.
More of a star forming / stellar object.
The beehive cluster. Yeah.
Yeah.
Actually, is the coat hanger just an asterism, or is that actually
Yeah,
a cluster?
Asterism.
It's
Yeah.
an asterism, yeah. There's the Antenna Galaxy and Corvus. That might be doable.
So what is the frequency of these planetary nebulae, and any object for that matter, have to do with like our understanding of how long a star lives? I mean, I would imagine there's a statistical analysis going on there. You know, we see a frequency of them in the sky, and we kind of can extrapolate.
Yeah, they think that one star in the Milky Way is born, and I think one star is dying every year.
Okay.
And in galaxies that are like that have active star formation, it's more like 10 a year. So when they have those like starburst galaxies that have got like a ton of stuff that's happening inside of them.
Right.
That's the first factor in the Drake equation, is rate of star formation.
Nancy's going to bed. Thanks, Nancy. I think we'll probably wrap things up pretty quick because it's pretty late. And actually, I'm quite impressed at how quickly we're able to kind of get all the images and stuff going. I mean, if we could get the sun, that would be amazing. But apart from that, I feel like we've hit all of my...
No pressure.
We've hit all my targets. Patience? Me? Come on.
See if I can get. Okay, I got a sun. Just for you, Fraser.
Futura.com is asking, when will Betelgeuse explode?
Well, not now, hopefully, because it's behind the sun. This would be the worst time of year for it to explode right now, about June or July. So it needs to wait till next winter.
It could explode any time between now and a million years from now.
Remember way back when, like 4 months ago, when that was the biggest news thing to talk about?
Yeah.
If Betelgeuse is going to explode.
Yeah.
It seems like years ago.
Yeah, boy, that was big news, wasn't it? Yeah, M104 is pretty close to the moon. I'm not going to be able to really get much out of it. There you go. Look at that.
Yeah.
Look at the sun.
The sun.
That's incredible.
The sun. The boring sun.
It's actually quite. We're in a profound minimum now. This is one of the deepest solar minimums that's ever been observed. So just the fact the sun is not very active is actually kind of an interesting thing going on right now.
Yeah. Couldn't get any flares of prominence around.
Yeah.
Couldn't get.
So you're talking about starburst galaxies. That would indicate some sort of galactic interaction, right? Like a collision, oftentimes, or some sort of tidal effects, right?
Yeah. So the starburst galaxies are the ones that have recently gone through some kind of galaxy merger, and so the interactions with some other galaxy is causing all the gas and dust to collapse into star forming regions, and they look dramatically different than the more boring galaxies that we like our own. And so at this point now we're in it's funny, we really missed the party of the universe. The party of the universe was back just a few billion years after the Big Bang itself. And now we are, we're seeing the universe, everything is kind of winding down. All of the really cool activity is all gone and done. And so now it's just this slow, continuous wind down until the end of the universe.
I'm looking forward to Milkdromeda, though, aren't you?
Yeah, exactly. Yeah, that'll be one event that, things will get exciting in a couple of billion years when Milky Way and Andromeda merge.
I'll know I've lived my life when I can see Milkdromeda. That's all I'm saying. So even if I'm on the cloud and I'm in my computer,
in your third robot body, you'll be able to see
I'll turn myself off after that.
Yeah.
Of course, about the time that happens, the sun's going to become a red giant, so we may not have a planet.
Yeah, well, you'll have a little bit of time. You'll have the. I mean, what'll really happen is the sun will have heated up to the point that it will have wiped out all life on Earth. So we get that in about 500 million to a billion years from now.
And the Earth's core is going to be, by that point, solid, and we're not going to have a magnetic field to protect us either, right?
I always think it's wild. There's going to be a point when all the galaxies, observable galaxies, will be up beyond the observable horizon. So any future civilizations will just think their galaxy is it. They would have no reason to think otherwise.
So I'll bring back my my Ring Nebula. Do I already have it still? Oh no, I closed it. Okay. All right. And so I'll show you. You can see the central star right in the middle of it. And we always argue about this. So if we decided that it is indeed the
white dwarf,
the leftover white dwarf,
I'm pretty sure. I think it is a 13th, 14th magnitude white dwarf.
In some of them it isn't. I know for some of the planetaries it's not, but I
know visually it's an observing challenge to try to pick out the central star. It's wild that on the photo it just pops right out.
Yeah.
There's some discussion in the chat regarding the solar cycles and the 11-year cycle, and just a note that's kind of interesting.
Yeah, I don't even see the chat here.
Yeah, like where are we on the cycle right now, David?
We're right about approaching mid-cycle here, 2019 or 2020, 2021. So, and then it's going to start being active again. But this 2020 is on track to be the most spotless. Right now, I think we've been spotless 78% of the time, which is quite a lot, over 3/4 of the days thus far, and we're almost halfway through 2020. So. It's probably going to be one of the most spotless years on record. I think it was 2009 was the last solar minimum. So, and the peak of this last one, because we're on cycle 25, the last one was 24. The peak for 24 was kind of lackluster. I mean, there was some big sunspots, but it wasn't really not like the sunspots we were getting back in the 70s and 80s. So
yeah. So I got a lot of sky glow. So here's your beehive.
M44.
Yeah.
That's almost spilling out of the field,
Yeah. So you can see I'm getting a lot of, I've tried to clean this up quite a bit, but I'm getting just a ton of sky glow coming
This
up,
one, at a good dark sky site, you can see the beehive cluster with naked eye.
And looks great in a pair of binoculars. Like you're talking about objects to look in a pair of binoculars.
Yeah, Pleiades, M44, those are all good open clusters.
Okay, well I think we'll get around to wrapping things up. So does anyone have anything else that they wanted to share before we
I've got one more coming.
Okay.
M10, which it's taking an exposure now, so
M110?
Or M10.
M10, okay.
That's about as far south as I can go in my backyard.
Yeah, again, I'm jealous. You've got the future. You've got all those objects that I won't be able to get for another 3 months. Yeah, look at it, way down at the horizon. It's all right.
Yeah, and for me, it's approaching the meridian.
Oh wow, okay. Yeah, that'll be nice. What else can I get?
But unfortunately, that's about as far south as I can get. My house is right about there.
Fraser, you want to try for the Antenna Galaxy in Corvus? You might be able to get that.
The Antenna Galaxy, sure.
That's NGC 4038.
Okay.
It's 11th magnitude, but I think you might be able to pull that out with this. It was one of the rare exceptions in this book that I went deeper than 10th magnitude. There was a few challenge objects I threw in here.
Let me see. NGC 4238.
4038.
4038. Okay. Whoa, where is the telescope going?
It's in Corvus, so it should be.
Maybe I'm doing a flip.
It should be. It's probably near the meridian for you. Yeah.
Okay. No, 4038. It's just below the moon. No, it's a little low for me. I think it's
too close to the moon.
It's too close to the moon. It's at 30 degrees, so I think I could get it, but it would be. Well, we'll see. I have to turn off the telescope, the camera in the telescope, because that makes it that you can light shines right down inside the telescope.
That's what I was going to mention.
Yeah. So whenever you have to warn me, whenever you can see down the barrel of the telescope, then I know that I need to recalibrate. Oh, there's your M10. Oh, that's nice. That's great.
They were asking in the chat if you are able to look toward the Owl Nebula, and I have it San Bernardino set up.
Yeah, I can do the Owl. Yeah, we did the Owl last week.
Major.
Yeah, I really like the Owl Nebula, but I mean, last week we had no moon. Next week we're gonna have a full moon.
Yeah, it should be full. I think it's it's full on January or June 5th because there's a penumbral eclipse.
Right. So we will be. That'll be next Saturday, right?
Sunday? Friday. Yeah. Friday.
Friday. Okay. Yeah. So we'll be a couple of hours after the moon.
Yeah.
After the the moon.
2 days.
2 days after. Well, so maybe the moon won't be up.
For the next star party. Yeah. So.
Yeah. Okay.
Theo Quasar is asking, is it true that most galaxies relatively near us no longer have active black holes and thus don't have quasars?
Yeah, we don't have any quasars relatively near to us. The closest quasars that we know of are in the hundreds of millions, even billions of light years away.
Yeah, I was going to say, I think the brightest one is 3C273 in Virgo, and I think that's 14th magnitude.
Yeah.
So I think that's in the range of 2.5 billion light years away.
Yeah. All right.
We could try for T2 Pan-STARRS again too. I have the coordinates.
You know what? I'm good with the picture that we took last week.
Okay.
Yeah, with the no moon. I have the feeling it's gonna. So I'll get a shot. I'm gonna download that shot of the antenna galaxy, which did come through. So.
Okay.
As soon as it downloads to my computer, and then I'm gonna get a shot of the Owl, and then, whoa, where's the Owl Nebula?
There's so many good questions here in the chat. I don't know if we wanted to keep going through some.
Sure, yeah, absolutely. Bring up the questions. Like I said, I'm trying to.
I'm trying to be helpful here, so hopefully.
Oh, I love it. I love it. Are you kidding? This is great.
Yeah.
Please.
Flip Anderson says, would be interesting if you could talk about the Milankovitch cycles and what effects it could have on global climate.
Yeah, I don't know too much about that.
Okay.
Yeah.
I mean, I could talk a little briefly on it.
Yeah.
So there are three main cycles that have to do with the Earth and its axial tilt. The shape of its orbit, which is its eccentricity, and also the position of the Earth on its axis due to the precession of the Earth's axis. And they're over three different time scales. And so I'm trying to do this off the top of my head, so if my numbers aren't perfect,
yeah, I think the one is 13,000 years. Is that right?
Yep, there's a 1,000-year cycle is the precession cycle, if I'm remembering correctly.
Yeah. So the seasons will flip every 13,000 years.
So you basically think of the Earth like an enormous top, and tops will start to, as they slow down, they'll start to precess. And so right now, the North Star Polaris, the North Star is Polaris or close to it. But that's not always the case. Over the course of 13,000 years, it goes through an enormous cycle. I'm feeling like that's 26,000 years.
26,000
Yeah,
years?
the precession of the equinoxes is 25,800. I remember
13,
researching that.
Yeah, 13,000 years from now, I think Vega will be the closest to the North Pole.
Yeah, Vega can be a pole star.
So there's that cycle. That's the 26,000 year cycle. Then there's an axial tilt change. And so like over the course, I think it's around 45 to 50,000 years or so, the Earth's axis is not always at 23.5 degrees. Sometimes it's a little less. I believe it's as little as 22.5 degrees. And sometimes it's as much as like 25 degrees.
Right.
And so that changes how we get the solar radiation from the sun, right? It affects your seasons. It's either more moderate, more extreme or more moderate.
Yeah.
And so that's a 45 to 50,000 year cycle. And the final one is the shape of the orbit. So like sometimes the Earth's orbit is more circular and sometimes it's more elliptical. And that changes over about 100,000 year cycle. And all three of these together can combine to create times when we are having extremes in one direction or another, where you're having a climate that would be colder or a climate that would be warmer. And that's the Milankovitch cycle.
There you go. Nice. So, and the relation that it has to climate. So it does have a relation to climate. It just doesn't have the relation to the climate on the kind of time scale that we're seeing. So you would, over the course of hundreds of thousands of years, see the climate change, temperatures change, depending on where we were.
Kind of a thing that I find most people are interested in is that we are actually at our closest to the sun in January.
Yeah.
And people are like, what?
Well, and that's one of the reasons why the Southern Hemisphere has more extreme weather than we have in the Northern Hemisphere. Like Antarctica is one of the reasons why it's colder than the Arctic, is because its winter is also when the Earth is at the farthest from the sun.
Yeah, we're going toward aphelion, I think July 2nd, July 3rd.
Yeah, and so we're entering the heart of their wintertime.
And
so
we
here's
also have a lot more land
here's your
in the
antenna
northern.
Galaxies, David. I wasn't able to make it happen.
blow it out a little bit.
Yeah, I mean, I've
out.
totally stretched this image. It's a mess, but I think these are they here.
Yeah, well, you can see the two interacting galaxies.
Yeah,
there,
yeah. The moon is just doing havoc on this.
Yeah. So that's why
we'll try for it another night when the moon's not
done with all of this. Yeah, I'm not even going to share that image with anybody. But I'm going to take my one picture of the Owl Nebula. I got about 6 seconds left, and then I think we'll start to wrap things up. I'll be doing my live show tomorrow on YouTube. So if you want to come join and ask me some questions about space and astronomy, I'll be around tomorrow at 5 p.m. Pacific time. And of course, we've got another episode of the Weekly Space Hangout coming this week. So if you want to join us for that, definitely do. All right. Come on, Owl Nebula. I'll share that, and then we will end the star party. And I'm going to say goodbye to some people here. So, Shah, people want to follow what you're doing. Where can they find out more about you?
Yeah, I'm mostly on Twitter, so you can find me on Twitter at Shahgazer, S-H-A-H, Gazer, G-A-Z-E-R. And I'm on Facebook, but mostly Facebook for my local friends over here in Malaysia. But I'm mostly on Twitter, and I got a Flickr account as well, shahgazer.net. So drop a line.
You've gone through a couple of Instagram accounts, right?
Yeah, I got an Instagram account called Shahgazer Returns.
Right.
Don't laugh at the name.
Well, because your previous one got shut down somehow, right?
Yeah. Just drop a line on Twitter. I'm on Twitter, mostly on Twitter.
Yeah. And definitely follow Shahgazer on Twitter. His Twitter account is amazing. All of the pictures that you're seeing, I mean, you're just seeing some highlights of it, but he's got one of the best technical astronomers that I've had the pleasure to know. So I'm so grateful for having you be able to join us here. And every hour that goes by, you're just going to get Venus like a little bit closer. Just keep breaking that record. That's awesome.
Yeah.
Funny.
And Linda,
It is on Wednesday.
where can people find out more if they want to watch your work?
So the primary place would be on Astrobin. My user ID there is, that's a good question, actually. I think it's just Linda.
Okay, yeah. Yeah, I think we saw a bunch of your pictures there on Astrobin. That was great.
Yeah, if you just look for, or my user ID there is AC4LT. It's my amateur radio call sign.
Oh, there you go. Okay, great.
And also on Instagram at LTFpics.
And David, where can people find out more?
Well, still writing for Universe Today, Sky and Telescope. Here's the first book.
Yeah, what a beautiful book.
And now I can show out July 21st. Here's the new book, Backyard Astronomer's Field Guide to the Night Sky. This covers all deep sky objects. Oh, and a friend of mine just put out a book. Michael Zeiler put out the Atlas of Eclipses for 2020 to 2045.
Oh,
it's
wow.
a beautiful book. I've been using his maps for years. Yeah, it's all eclipse maps, like really extensive maps for every eclipse, like starting with the eclipse this month, as a matter of fact. So everybody's got a book.
There you go. David, Farina, do you have a book?
I don't have a book, but I was actually interested in writing a book someday.
All
so
right.
I'd love to talk to the other David at some point.
You have your whole life to write your first book, and then you're on a deadline for your second book. So
Yeah, we'll see if you do decide to write now that Dave has written 2, he's hooked.
I'm now in the
Mine
class
will
of
be
authors. We did an ebook. We did a guide, me and Fraser,
Yeah.
for 2017. So technically, I'm on book 3.
I guess that's true. Yeah.
Publishing is on my timeline then.
Yeah. And then as he says, once you get the first one out the door, then you're hooked. All right. So here's my Eye Nebula. I'll bring that up now, and then I'll use that as our saying goodbye to everybody. I think this is all right.
Oh, you got some color in it.
Yeah, I'm a little out of focus again, but there it is. So, thanks everyone for watching tonight. Thank you for all of the astronomers joining us tonight. I think that worked out really well. We hate you, Moon. Get lost. As soon as we can, we will destroy the moon. We will see. But next week, man, it's going to be rough. Pretty much a full moon. We'll see if hopefully we can sneak out the star party before the moon shows up. We'll see how the timing works out. But yeah, thanks everyone for joining us tonight, and we will see all of you next week. Thanks everyone.
Thanks, Fraser.
All right.